So water efficiency on our LEED for existing building projects, two things you have to do, remember on your exam, when you see words like must, have to, you have to do those. Those are prerequisites. You don't get any points for those. 110 possible points. We've got to meet all the prerequisites. Then we get into our optional credits. We have our outdoor water reduction. So on new construction projects, you can actually earn a little bit more credit here on the outdoor water side. On existing buildings, still 1 or 2 possible points. Are we able to use some non-potable water? Are we able to just be more water efficient? You know, what's our setup here on our site, our existing site? If any of you have landscape projects, you're going to come in and modify your irrigation, you're going to modify your landscaping, that kicks in these points as well. And then we're going to talk about inside, in the restrooms, okay? Inside our existing commercial buildings. Now, some of the buildings I've worked on, say here in Atlanta where I'm based, you know, sometimes if you haven't kept up with your retrofits in your restrooms, saving water on your urinals and toilets and faucets, LEED for existing buildings is going to force you to do so, because we've got a prerequisite indoor water use reduction. We've got to hit a certain 20% savings essentially over code. But if it's an older building, they give us a little leeway. But the more water efficient we are, well, the more points we're going to get. 1 to 5 points there. Cooling towers with LEED version 4 are worth more points than in LEED version 3. And water meter. We want to make sure, can we sub-meter our cooling tower makeup water? Can we sub-meter our domestic water? Can we sub-meter our irrigation? So sub-metering gets us some extra points. Let's start with the prerequisite though, okay? Indoor water use reduction. What do you have to do? Indoor water use reduction. Well, we've got to come into the restrooms, and on existing commercial buildings, there's actually 2 points. There's actually 2 options here: calculated water use or metered water use. So option 1 is the one we use most of the time, and we can actually, depending on when the building was built, and it says 1995, but it's really kind of a 1994 cutoff, if it's before 94 or after 94. So depending on how you read it in the reference guide, let's just say 1992, the Energy Policy Act came out. We were trying to save energy in our buildings, but also save water. By 93, 94, we were updating our plumbing codes in the United States. And for those with you that are international customers here, trying to take your LEED APL&M, just realize we are going back, taking a look at, in the United States, our plumbing codes, our UPC and our IPC plumbing codes, Universal International Plumbing Codes, because then that usually gets adopted by our local municipality. With LEED for new construction, or here LEED for existing buildings, we actually just look at more of the national code. Are our toilets and urinals and faucets and shower heads, are they more efficient, 20 to 30% more essentially than current plumbing code? Okay, so let's take a look at that. On your exam though, you want to take a look at, was the building built before 94 or 95 or after? If it's after, we essentially have to follow current plumbing code. If it's before, they actually give us a little leeway, and when you do this kind of calculation, it's kind of a weighted calculation. Now with LEED version 4, they really want us to push towards the WaterSense label, okay? Can we make sure that the fixtures we're buying, WaterSense labeled? The WaterSense label is an EPA standard. You might need to know that for your exam. All right, so on your exam, and some of you remember this from your LEED Grant Associate, we have our water closets, our toilets, 1.6 gallons per flush. On your exam, that could be written as parentheses 6 LPF, 6 liters per flush. We need to make sure our urinals, 1 gallon per flush, that's code, but how are we going to get more efficient? Well, we might drop those down to say pint flush. That's a good option here. Our public lavatory restroom faucets, 0.5 gallon per minute is code. Private lavatory faucets, this is pretty rare, but if someone had like their own private office and it had a restroom, and not the general public could access it, you're allowed a little bit higher, 2.2 gallons per minute. Kitchen faucets, 2.2 gallons per minute. Shower heads, 2.5 gallons per minute, okay?
So we go into standards for appliances. Now, Charlie mentioned that there's the baseline that we want to reach. And so as you mentioned, around 95, programs started to be implemented, codes started to get a little bit stricter. So when you're looking at appliances, these are the standards that you want to be able to meet in your building. Things like for a clothes washer, Energy Star. Energy Star is always a great label to see on appliances. CEE Tier 3A if you're going commercial. Energy Star again for dishwashers and for ice machines as well. And then for pre-rinse spray valves, we want to get kind of that lower gallon per minute flow rate. And so, as Charlie mentioned, we've got, you can either calculate the water usage in your building, or you can go into option 2, and this is with metered usage. Now you'll notice in this credit especially, USGBC loves to see your building be metered. They're really, they really put a lot of emphasis on knowing what your building is using. So you can go from there thinking, okay, where's my next step? So if you have meters already installed in your building, then your baseline can be fit from your own building rather than just a generic code fixture. So you want to record that meter data for a year or more to establish a baseline. And this is one of the reasons why, your building needs to be in operation for a year before you can go for O&M. So to even consider this option, you have to have those meters in place. And then 80% or more of those fixtures need to be metered to show that water use baseline. So if you're only metering 20% of your building, of course, it's going to look great. It's going to look like you're not using any water. And so that's why USGBC says, all right, we need to see 80% of the water usage in this building metered so that we can get an accurate picture. And if you're thinking, all right, well, the baseline's from our own building, what's going to be our next step going forward? And so this is a good fun fact. We're thinking, why is water usage important? Why is it's so heavily relied on in LEED? 47% of the water used in most office buildings is used by the restrooms and mostly by the toilets. So when you think of all of that water that goes into running a building day to day, there's a lot of availability to reduce that water usage. So for example, especially if you're looking at retrofitting, if you're looking at redoing restrooms, even in redesign, looking at ultra low faucets, shower heads, and again, that WaterSense criteria is going to be a big one in the O&M. If you get a water question and you see something with a WaterSense label, a bell should go off in your head. Aerators are another great option if you want to reduce your water usage, but you don't want to redo all of the faucets in your building. Aerators are a great option. I actually had a building in Chicago, right in downtown, that was only getting about a 20% reduction in their water usage. And so the team and I talked, and I said, okay, you can buy these low flow faucet aerators from Home Depot for however much, $5 an aerator. And it's going to be a little bit of a cost up front, but you'll save 1 million gallons of water a year for your building just by installing these aerators. So if you're thinking, absolutely, I want to go for LEED, I want to reduce my water usage, but I can't redo 30 to 60 floors of a building, aerators are a great first step to reducing water usage. Dual flush toilets and flushometers are another great way. You've got the low flow one way, and then the general baseline flow another way. Waterless urinals are another great option. So you might be thinking up front the cost is a little too much, but there's a 3-year payback for waterless urinals because all of that water you don't need anymore. So our next prerequisite, which as Charlie mentioned, this is one that you have to go for in LEED, is that building level water metering. And if you see a question on the exam, something like, why does LEED want to see all this metering? A lot of it is that they want transparency. USGBC wants to see how these buildings are doing. A lot of the questions in the AP are going to be why? Why is this important to the USGBC? Why is it important for your building? And so USGBC wants to see this data, wants to see that consistent improvement in the market. And so for this prerequisite, we want permanent meters that measure the total potable water use on site. So this is building and grounds. Again, might be another question they try to slip by you saying, oh, what needs to be metered on site? For this credit, if it's irrigation using potable water, we want that metered as well. Gray or reclaimed water, if you're using captured rainwater, that's recommended, but it's not required. So for our prerequisite, if it's potable, yes. It's gray water, not necessary. And so we want this data to be recorded monthly, and it could be manual. You could have an engineer go out and read it once a month, or you can have those automated readings. And the USGBC wants you to commit to sharing that water usage data for 5 or more years once the building receives its certification. And so using those 2 prerequisites, we can go into our credits. And these are the ones that are all optional. But if you're running a project, these are some great ways to earn some points. Now, for our outdoor water use reduction, we have 3 options here. Option 1, no irrigation required. Our landscaping is self-sufficient. Rainwater is all we need. Great, 2 points. You could also go for option 2. And these are all, ors. Unfortunately, you can't stack the points and end up getting 6. There's a max of 2 points in this credit. So if your landscaping does require irrigation and you don't have a meter installed, then you can calculate how much water your landscaping needs. If you do have that irrigation meter installed, then it's just a matter of reading what your meter tells you. So our option 1, say for reduction, then we want to see 30% below the baseline gets us 1 point, 40%, 2 points. And again, that no irrigation automatically gets us 2 points. So looking at no irrigation, USGBC does give you some leeway. And let's say you've just started out, with your landscaping and you need 2 years to make sure that your plants take root and that the landscaping is growing as it should. They give you 2 years to get that established, and then no more irrigation is required. So that's in performance. There's nothing you need to do during the performance period of your building because you've already established, yep, our landscaping is good to go. Option 2, it's a little more intense. Now they want to see you calculate water budget. And so this is a good term to remember. The EPA WaterSense water budget tool is a great thing to keep in mind when you're studying for this test. And so calculating the landscaping requirements, this also, if you're filling out this credit, it walks you through it very clearly. So if you're thinking, how in the world am I supposed to calculate how much rainfall comes in my area? Am I supposed to take a graduated cylinder out there every day? That's what the EPA's WaterSense budget tool is for. It already has all of that data uploaded. So what you would need to do is calculate the vegetated areas on your property. So the building doesn't need to be counted, no parking garages, nothing like that, no mulch areas, just the vegetated areas. And they're either low, medium, or high water users. So if part of the landscape is irrigated, this is another good thing to remember. You want to run the calculation for irrigated and non-irrigated. And so your next step is going to be to input those plant species and the arrangement so that the water budget tool gets a sense of how much water this landscaping is going to need. The evapotranspiration rate, which is another good term to keep in mind when you're studying this credit, is thinking, okay, how much water is the sun going to be taking from these plants during the critical month of the year? So think the hottest month of the year around your climate. That's what the EPA water sense budget tool is going to be thinking about. What's the max amount of water your property is going to need? So it calculates that baseline requirement for your typical landscape. And that is going to kind of give you that baseline of what your property requires. So once we've used that tool, we calculate the adjusted landscape water requirement for any alternative sources. If you have an irrigation pond on site, if you're collecting rainwater, or if you have smart irrigation controls, which we'll get further into in this credit. So if you have smart sensors that meet that water sense criteria, again, water sense, that bell goes off in our head, then we get an additional 5% reduction in this tool. And again, USGBC is very big for existing buildings on calculating and sharing data. They want people to be aware of how their building is performing. So with this credit, if you don't have an emitter installed, then they want you to install that irrigation meter. Very important to the USGBC. They want people to know how their buildings are performing. And so again, we saw this in our table. Based on the water use reduction calculations, if you show that your landscaping uses 30% less, then you get 1 point. 40% less is 2 points. And our final option for this credit is if you do have that irrigation meter installed and your landscaping requires water, you can establish your own baseline using the annual average of 3 consecutive years worth of data from the past 5 years. So you may be thinking, all right, great, I'm using my own baseline, but again, how am I supposed to achieve a 30% reduction from my building usage? And that is where our improvements can kind of come into place. So we'll go over a few items that you can look into if you're thinking about improving your landscaping, improving irrigation, and some of the items that you may see on the O&M exam. Again, 30% reduction will get you 1 point, 40% reduction, 2 points from your building's baseline. So we're thinking, okay, well, option 1 seemed the easiest, and so how could I design landscaping that doesn't require irrigation? And so you may have heard the term xeriscaping. So it's a style of landscaping that requires little to no irrigation. So a great thing to look at is using landscaping that's native to the area your building is. I know xeriscaping is getting a lot more popular in the drier, more arid climates, with plants that don't require a huge amount of water that the area just is not receiving. So to reduce the amount of irrigation, we're going to plan and design using practical turf areas. We don't want too much open space that's going to require a large amount of water. And again, native adaptive plants like we just talked about, and efficient irrigation strategies like some drip irrigation. This is a great option. And if you see this question on your O&M, you may see a question saying, okay, what's a good way to reduce irrigation needs on site? Drip irrigation is a wonderful option because it waters the plants directly without using a large amount of water. As the name implies, the water just drips out of the hose right onto the plant. So you're using a minimum amount of water to get the maximum effect here. So here's a practice question everyone can take a look at. A project team is attempting a 100% reduction in outdoor water use by harvesting rainwater. What will need to be confirmed? A, the rainwater storage system is submetered. B, the water needed in the peak month can be stored on site. C, the rainwater system is connected to the potable water supply. Or D, the submeters are water sense labeled. Here, as you're thinking about the answer, let me warn you, I told you water sense should ring a bell in your head, but don't be drawn in by vocabulary that you recognize. This would be where the GBCI is trying to test you. You know that water sense is great for water usage. That's what you want to see in your building, but does it actually have any relevance to what they are asking? think about, okay, think about that WaterSense tool, what you want to make sure your building has for landscaping for the entire year. So my hint may have given it away, but the answer is the water needed in the peak month can be stored on site. So if you remember from our talking about the EPA's water tool, they look at the evapotranspiration rate from the hottest month of the year. So we want to make sure that the water stored on site can meet that need for our landscaping in the hottest month of the year. So another great option is if you have the ability, you can store rainwater on site. I had another building in right outside of Atlanta that had a huge irrigation pond, and so they were able to use all of their irrigation water from the captured rainwater on site. Now let's say you don't have the ability to capture rainwater, but you want to look into those smart controls. Now see, this is where WaterSense does come into play. This way we can tailor the watering schedules to the site conditions. So instead of just say at 6 a.m. the sprinklers are going on and they're going to go back and forth for however long and turn off and then turn on again, exact same time, the exact same morning. I don't know if any of you have ever seen this, but sometimes it'll be raining. I'll be walking past the property and their sprinklers are going while it's raining. And you're thinking, okay, well, is that really necessary? Does the lawn need to get double watered? And so that is what these smart irrigation controls can stop from happening. So you use the local weather and the landscaping conditions to kind of set this system. So if it's going to rain tomorrow, then you know your irrigation controls aren't going to come on and waste that much more water. So we've got another practice question here. Which area should be excluded from the landscape area calculations for WE credit outdoor water use reduction? So give us a second. And so the answer here is permeable pavement. So you only want to include vegetated areas for outdoor water use reduction. So just as a quick reminder for this credit, we want to either have no irrigation for our outdoor areas or establish that baseline and then try to implement either smart irrigation tools or good technology that makes sure that we are watering the landscaping as effectively as possible. So the next credit we're going to talk about is indoor water use reduction. We've covered the outdoors, now we're coming back inside. And we've got two options for this credit, either calculated water use or metered water use. And so here are the percentages we're looking at. This credit ties in with that prerequisite, meeting the baseline. And so if we reduce our water usage beyond that prerequisite baseline, we earn more points. So this 10% is the 10% reduction from the prerequisite. So reduce 10%, 1 point, 15%, 2 points, 20, 3, 25, 4, and 35. Good note here is that the exception to this is data centers. That's just a good thing to keep in mind. And then for reduced metered water use, we want to see less than 5% is 1 point, 5% 2 points, 10% 3, 15% 4, and 20% 5. So the numbers are a little bit lower for metered water use because the baseline is created from your own building's water usage. Good note here, adaptations for schools. The days of operations would only be 195. So for water usage, they want to see how many days of the year are people going to be using the water inside the buildings. Just good to remember for schools that those days are going to be a little bit less. So indoor water usage is very similar to the prerequisite. It's just additional points based on how well your building does. Credit 3 is going to take a look at that cooling tower water use. So for cooling towers and evaporative condensers, LEED requires one potable water analysis for those cooling towers. And in that analysis, these are good to remember for the exam as well. What needs to be tested in that potable water analysis? There's 5 control parameters, and these are the maximum concentrations allowed. So what we have for calcium carbonate, we have 1,000 parts per million, alkalinity 1,000 parts per million. For silicates, we want 100 parts per million, chloride 250 parts per million. The conductivity, we want to keep at 2,000. So those are good to keep in mind as well when you're reviewing. Have a general idea of the parameters that this analysis is going to take a look at. So cycles of concentration, this one is good to know. This is a question I got on my O&M on how do you define cycles of concentration. So it's those acceptable maximum concentrations on that slide we just looked at. Back here. The acceptable maximum concentrations divided by what's actually in our makeup water. So that's how many times that we can run the water through our cooling tower. So if the maximum number of cycles achieved without exceeding the levels is 2, or, and then again, we want to remember that data centers are separate on this one as well. Data centers, where it comes to water, are often separate. And so if we achieve a minimum 10 cycles by increasing treatment, or achieve the number of cycles for 1 point and use recycled non-potable water, then we get 3 points as well. So for cooling towers, we want to maximize those cycles of concentration, minimize our makeup water. Cooling towers are also a great way to use if you have non-potable water that you're not using for irrigation. Cooling towers are another great place to have that non-potable water usage. So if you're wondering, makeup, we saw that in the last slide. Makeup water replaces the water lost through evaporation just from the cooling tower running, blow down, and drift. And our non-potable sources for makeup water could be air handler condensate, cooling system water, pre-treated effluent, or recycled wastewater. So again, a great place, or if you have recycled water that might not be potable, but you're looking to use it so it doesn't go to waste, cooling towers are another great option. Our next credit is going to be water metering. And so we want to establish permanently installed meters in the building. So this credit is not feasible unless you have those permanently installed meters in the building. If you have 2 subsystems metered, that's 1 point. And if you have 4 or more subsystems metered, then that's 2 points. If you're thinking subsystems, what could that be? We're looking at irrigation, specifically indoor plumbing, fixtures, and fittings. So if your plumbing is metered separately from the main building, that could be a subsystem. Cooling towers, hot water, reclaimed water, or other processed water are also different types of subsystems. But the USGBC also has requirements for each subsystem. So for irrigation, 80% of the irrigated landscape has to be metered. So not all of it, but 80%, and 80% of indoor plumbing needs to be metered as well. For cooling tower, they just want to make sure that the building is metering the replacement water use for all cooling towers. Domestic hot water, 80%. Reclaimed water, 100%. And finally, any other processed water, 80% of the expected daily consumption needs to be metered. So processed water would be anything like humidifiers, dishwashers, clothes washers, or pools. So these numbers are good to have kind of in the back of your head when you're thinking, okay, well, what items would need to be submetered to earn me these points, and then what percent of that needs to be submetered. So for the performance, the whole building and those subsystem meters need to be recorded at least weekly. So we want to calibrate those meters to the manufacturer recommended interval so that we make sure the meters are working appropriately, they're taking in the information we need. And again, we want to commit to sharing that data with the USGBC for 5 or more years. So getting into synergies, synergies are another favorite of GBCI to ask about. I had a question on my exam that said, if a project team implements rainwater management activities, what other credit could that benefit? So you might see some questions saying, oh, the building does X, what else would that affect? So let's talk about some synergies. With that outdoor water use reduction, we also tie into sustainable sites, rainwater management. If you have landscaping that helps reduce the amount of rainwater that could be going into the sewage systems, those can tie in together. It can also tie in well with energy performance. If you don't need to use any irrigation on site, then you don't have to pump that water out through your irrigation system. Similar, indoor water use reduction. If you've got low flow fixtures, waterless urinals, or even better, you manage to capture rainwater and use that gray water in the toilets, then that's the way these two credits here can work together. Energy performance, same way. If you are not flushing as much water down, less energy usage. Commissioning as well. It's a great way to save energy in your building while also helping save water. And cooling tower use, this ties in as well, because if you're able to maximize the amount of water you're using in your cooling tower, then that's less energy your building needs to use there as well.